This video is sponsored by PCBWay, so before we get started, let's thank them for supporting us. If you're not familiar with PCBWay, their goal is to be the most professional PCB manufacturer for prototyping and low-volume production work in the world. New customers get a $5 bonus on their first order. Thank you, PCBWay!
I recently came into possession of this amazing vintage Space Invaders arcade cabinet. The cabinet itself is in fantastic condition, but the electronics leave a little bit to be desired. It looks like someone bypassed the edge connector and routed jumpers directly to the board. Additionally, the screen only shows these bars when the cabinet is powered on.
So what's really bizarre is when I picked the cabinet up from the previous owner, it actually worked more than this. It still had problems, but it actually worked. And what it would do is it would boot up to the Space Invaders screen and it would put the characters on the screen, but then immediately after it would say CRC parity error, I believe is what it said, which I suspect is just a bad RAM chip. But after transport, now we got this. So I suspect during transport it got jiggled and some things happened and who knows. But based upon the wiring job that's in the back, we got a lot of work to do anyway, so we're going to go ahead and just fix it all in one fell swoop.
The first thing I did was take some tape and make some labels for these jumper wires. I then labeled each jumper at the harness side and the board side. I then went to cutting all of these jumper wires, and the labels just give me a backout plan. And finally, I was able to liberate the board set and remove it from the cabinet. This is a Midway L-style board set, and it looks like it was last serviced by Chuck in 1980. Chuck, I hope you're still doing well. After I studied the board for a bit and tested everything with a multimeter, I came to the conclusion that there are two problems with the board. The contacts on the edge connector are in bad shape and need to be fixed. But it also looks like someone didn't understand that the Space Invaders harness connector is bridged, meaning the pins on the front and the back are the same, but they replaced the factory edge connector with one that is not bridged. This means if you solder to one side of the connector and the board expects a signal on the opposite side, things aren't going to work. So I began removing all of these jumper wires and then using the vacuum iron to remove the leftover solder blobs. I then went back and cleaned everything to remove the flux residue. And I checked one last time to make certain we still have continuity. To repair the edge connector, I'm using a solder and wipe method. This builds a new layer up over the connector and fills in all of the gouges on the pad. No, this isn't a perfect method, and yes, I am aware it might oxidize over time, but there is no reason to take on a more drastic repair at this point. So with the board set cleaned up, I turned my attention to cleaning up the harness. I started by removing the other side of these jumper wires. Where they had made splices, I cut them open and clipped the leads off. I then stripped the wires back and soldered them together using my quad hands helping hands to keep everything in place. Next, I put heat shrink tubing over all of the repaired wires to keep them from shorting. And finally, you can see here how I bridge the edge connector to make the signal appear on both sides of the board's card edge. And with everything back to normal, I put the board back in the cabinet. Unfortunately, the game still doesn't work, but we have made progress. Instead of the horizontal lines, we're getting some garbage. I believe garbage points to a bad RAM chip, which makes sense because that's the problem the original owner was having. Before messing with the RAM, I tested all of the grounds and voltages around the board and indeed found that my negative 5 volts was not working. After a little probing around, I found out that the negative 5 volt line had a broken trace at the card edge. This explains one of those jumper wires at least. To repair this correctly, I added a bodge wire to bypass the missing trace. I then tested the board again and indeed had negative 5 volt everywhere I expected for it to be. This didn't fix our main problem, but it did change the garbage and make the screen a lot brighter. I've heard that providing plus 5 volts to the 8080A without a negative 5 volt supply will pop them, so I quickly tested the 8080A by replacing it with one from my parts bin. No change. I popped the ROM from socket H. This is supposed to make the machine show test bars on the screen, however, I still get the garbage. In the Midway repair manual, it says if this happens, to test the RAM by shorting pin 7 on each of the RAM chips. You can then tell on the screen by the garbage changing which chips need to be replaced. It looks like I have at least 3 bad chips. I've also been told that due to the poor design of these boards, that every RAM chip will eventually fail and need to be replaced. With that in mind, I decided to just desolder all of the RAM chips and put sockets on the board to make future repairs much easier. So I got busy with the Hacko and started removing all the chips. And a few minutes later, I had a nice pile of RAM chips and an empty board. Now to install the sockets, and I can't wait to hear the debate in the comments over dual leaf versus turn sockets and which ones I should have used. If you don't shoot YouTube videos, then you have no idea how hard it is to solder with camera gear between you and the board. And with the flux washed away, it doesn't look too bad. Lots of happy sockets ready for some new RAM chips. And after testing the chips, I found 2 of them to be bad. So we'll install these 2 replacements that I got from eBay. And unfortunately, we still have the same problem that we had before. But one thing I noticed is that now when I place the test ROM in, it actually boots. All of the tests passed except for the shifters test, which gives me the following error. I believe this means that one of the first 2 multiplexers is bad on the daughter board. I'm not sure which one, so I just replaced them both. And that seems to have fixed that problem. However, with the original ROMs back in, we still have the same issue. But I noticed that on the test ROM screen, that the CRC for ROMs E, F, and G were all showing the checksum of a blank ROM, even though they're clearly installed. So a little fiddling with my logic probe, and I noticed that the chip enable on ROM E seemed to be stuck. So I placed a new EEPROM in my programmer and burned a brand new ROM E. I placed the ROM in slot E, and we have Space Invaders. This brings a tear to my eye. Just to make things easier to troubleshoot in the future, I went ahead and put labels on all the ROMs with their location and correct CRC.
Well, I could not be more thrilled with how this project turned out. It's always so rewarding when you take something that's been abused or ignored for probably a decade and bring it back to life and make it work like new again. Well, if you like this type of video, be sure to like and subscribe, and I'll see you in the next one.